welcome back to the deep dive. Okay, so you've sent us quite a pile of sources this time, all centered around something that honestly still feels very sci-fi. Quantum teleportation and how it links up with quantum computing.
Mm-hmm.
Our job today, as always, is to unpack all this, the articles, the research, your notes, pull out what really matters, and try to make sense of it all for you.
And maybe let's just get this out of the way right at the top. We should probably forget the Star Trek transporter idea for now.
Right. No beam me up, Scotty, just yet.
Not quite, but honestly, the real-world stuff that's actually being worked on now, you could argue it's even more revolutionary in practical terms than that kind of sci-fi dream.
That's a big claim, and it seems like it all hinges on that big step forward at the University of Maryland's Joint Quantum Institute. That felt foundational in these readings.
It really was. Because they didn't just teleport information, like the state-of-light particles. They managed the successful teleportation of particles with matter, actual atoms.
Okay, and that wasn't just like a neat physics trick.
No. It was pivotal. It basically opened the door, theoretically at least, to these, well, pretty incredible possibilities we're going to talk about. It moved things from the realm of just abstract data to potentially moving, well, actual stuff.
Stuff at a fundamental level.
Exactly. And that's the bedrock for pretty much everything else we're looking at today in these sources.
All right, let's dig in properly then. We have touched on the basics of quantum mechanics enabling this before, but maybe we should quickly revisit why that Maryland experiment was such a big deal. It seems crucial for understanding the applications.
Yeah, it's worth stressing the difference. See, teleporting the state of a photon light had been done. That's essentially information. But what they did was demonstrate transferring the entire quantum state of an ion, that's a charged atom, actual matter, to another ion some distance away.
Without anything physically traveling between them.
Correct. No physical connection. The state doesn't travel through the space in between.
Oh,
well, it's the quantum weirdness. But they showed it works for matter. That was the leap.
Okay. A leap that, if you read these sources, could lead to something massive in the physical world, completely shaking up transportation and logistics. They're framing it as possibly the biggest shift since, the shipping container.
It sounds dramatic, but think it through. If you can move matter instantaneously, okay, maybe starting small, but the principle is there without needing trucks, ships, planes.
The cost just vanishes?
Well, potentially. The cost of shipping could plummet towards zero. Think about the energy, the infrastructure you wouldn't need.
Okay, that sounds almost unbelievable, near zero shipping. But the sources immediately point to oil and gas, right, as a concrete example.
Exactly. Picture this. No more need for thousands of miles of pipelines or fleets of supertankers or all that complex, expensive infrastructure just to get oil or natural gas from A to B.
But it doesn't just save money.
Not at all. It would totally reshape global energy markets. Suddenly, where the resources becomes less critical than the ability to, teleport it, it could shift geopolitical balances quite significantly.
And then there's the angle that probably jumps out at a lot of people listening. The environment.
Oh, yeah. If you start replacing traditional cargo ships, trucks, planes with this, think of the drop in greenhouse gas emissions.
Huge. It would slash the carbon footprint of global trade.
It's a fascinating link, isn't it? This really fundamental physics potentially offering a powerful tool for, maybe helping meet climate goals, less burning fossil fuels just to move things around.
Okay, so that's moving goods and resources. But then the sources shift to something even more personal, maybe. The potential impact on the human body, on medicine. This stuff sounds even further out there.
It does, but it follows the same logic. They talk about a concept called selective quantum exclusion, maybe for cancer treatment.
Selective quantum exclusion. How would that work?
Okay, so the idea, based on the principles of teleporting individual particles, is you'd map a patient's body at an incredibly detailed quantum level. You'd identify the cancerous cells by their unique quantum state. And then, through a controlled quantum process, sort of like a highly targeted teleportation or state transfer, you could theoretically exclude just those specific cells, leaving all the healthy tissue completely untouched.
Wait, hang on. So instead of cutting tissue out or using chemo or radiation that hits everything, you'd just sort of quantum filter the bad cells. Is that the idea?
Kind of, yeah. Leveraging that particle-level precision that quantum mechanics allows. It sounds like sci-fi, but the physics principles are there. The precision would be unreal compared to current methods.
Wow. And it doesn't stop at cancer, does it? They mentioned cosmetic uses.
Right. Things like precisely removing or altering scars, birthmarks, other features at the molecular level.
So non-invasive alternatives to surgery, but hyper-precise.
Exactly. Imagine reconstructive surgery or fixing disfigurements with that kind of accuracy and potentially much less trauma for the patient.
And then there's the genetic angle. That seemed huge, too.
Potentially, yes, if you can understand and manipulate matter right down at the quantum level. The idea is you could eventually correct genetic defects, maybe even edit DNA sequences with pinpoint accuracy.
Addressing the root cause of genetic disorders.
Offering hope, maybe, for conditions we currently see as incurable. It's mind-boggling to think about, honestly. But the theoretical path starts with manipulating matter particle by particle.
Okay, let's shift gears a bit from the physical body to the digital realm, communication.
Mm.
The sources seem to suggest this quantum communication might be one of the sooner applications we see making a real impact.
That seems plausible, yes. It leans heavily on quantum entanglement.
Ah, right, entanglement, where you have pairs of particles, usually photons, linked together.
Linked in a special way so that they stay connected no matter how far apart they get.
And the key thing is, if you measure one, the other one instantly reflects that change, right? Across any distance. Instantly.
That's the core idea, that instantaneous correlation. And what's really interesting is how this just bypasses huge problems we have with current communication.
Like what?
Well, things like signals getting weaker over distance and needing amplification, or needing massive data storage at relay points, or just the sheer complexity of networking all these nodes together physically.
Stuff our current internet deals with constantly, with all the
Yeah.
fiber optic cables, satellites, repeaters.
Exactly. These sources talk about a potential quantum internet, and it wouldn't just be a faster version of what we have. It would be fundamentally different.
How so?
Because that entanglement correlation is instant and doesn't really degrade like an electrical or optical signal does. You might not need all that physical infrastructure in the same way. Data isn't sent bit by bit through a cable. It's more like the state is shared or correlated instantly between entangled points.
Okay, the implications of that are pretty huge too. Cheaper global networks.
Potentially, yes. A massive drop in the cost of building and maintaining communication infrastructure. Plus, potentially exponential increases in speed. And this is crucial inherent security.
How's it more secure?
Because the very act of trying to eavesdrop on an entangled communication disturbs the quantum state in a way that's immediately detectable. It kind of breaks the entanglement.
So built-in eavesdropping detection.
Yeah.
That's a total rewrite of communication technology.
It really could be. And underpinning all of this, the transport, the medicine, the communication, is the engine driving it. Quantum computing.
Right. You can't do most of this complex quantum manipulation without the processing power to handle it. And quantum computers aren't just faster classical computers, are they?
Not at all. It's a completely different approach. Your standard computer uses bits, zeros, or ones. Quantum computers use qubits.
And qubits can be 0, 1, or somehow both at the same time.
Exactly, thanks to superposition. And they can also be entangled with each other. This allows them to explore a vast number of possibilities simultaneously, tackling problems that are just impossibly complex for even the biggest classical supercomputers. It's a whole new way to compute.
And it feels like things are moving fast there. IBM putting their quantum computers on the cloud was mentioned as a big step.
Huge step, made the tools accessible to researchers everywhere, really sped up development and experimentation, democratized it in a way.
And then there was Google's big claim a few years back, quantum supremacy.
Right, back in 2019, that was a critical moment. They showed their quantum processor could solve a specific, carefully chosen problem in minutes.
A problem that would take the world's best supercomputer, like thousands of years.
Something like that, yeah. It was the first real demonstration that quantum computers could actually do something practically impossible for classical ones, a proof of principle.
And the applications for this kind of computing power go way beyond just enabling teleportation, right? The sources listed a bunch.
Oh, absolutely. Things like revolutionizing drug discovery. Imagine simulating exactly how complex molecules interact. Or optimizing incredibly complicated financial models, solving huge logistics puzzles for manufacturing or city planning.
So quantum computing isn't just a tool for these other quantum technologies.
No, it's a fundamental new capability in its own right. It's going to likely unlock breakthroughs in fields that have, nothing directly to do with teleportation itself. It's the underlying processing power.
Okay. So looking at the big picture, we've got these potentially world-changing applications powered by this new kind of computing. But
Yeah.
it's important to manage expectations, right? The sources are clear. This is still early days.
Very early days, absolutely. There are massive engineering hurdles, theoretical challenges still to overcome before, you're teleporting your Amazon packages or getting quantum cancer treatments. We're not there yet.
A lot of work still needed.
Definitely. And the sources also flag the next big area, which is critically important and tied into all this. Security. Quantum cryptography.
Ah, right. If quantum computers can break today's encryption.
Then we need quantum methods to protect data. It opens up vulnerabilities, but also offers potentially revolutionary ways to secure information. That's probably a whole deep dive on its own for next time.
Sounds like it. A whole new can of worms, as they say. But okay, wrapping up for today, the main takeaway seems to be, yes, personal teleportation is still firmly sci-fi territory for the foreseeable future. But the underlying science, the ability to manipulate quantum states to teleport matter particles, is real.
Yeah.
And the applications being actively researched and developed right now in transport, medicine, communication, computing, they're already starting to lay the groundwork for some really fundamental changes to the world you live in.
Which leads to, I guess, a final thought for you to chew on. How might these, kind of abstract-sounding quantum ideas, moving particles around instantly, processing information in these weird new ways, how might they fundamentally change parts of your everyday life that you just take completely for granted right now?
Like what?
Like the price of stuff you buy because shipping costs changed. Or how diseases are treated in the future, or just the speed and the very nature of how you get information, how you connect with people across the globe. It's worth thinking about how deep those changes might run.
Definitely food for thought. Thanks for joining us for this deep dive.